All right, I hope I can fit this entire one on this small little board here. This is going to be kind of a long problem. Okay, so on this one, we have distinct linear and quadratic factors. So again, I've got a rational function and I want to factor the bottom as far as it'll go. So this will become x times x minus 1, x squared plus 4. Now, I cannot factor that. It would be imaginary. We don't want imaginary stuff. So that's as far as I'm going to be able to take that thing. Okay, so we're going to take 2x cubed minus 4x minus 8 over x times x minus 1 times x squared plus 4. Now, what's that going to equal? Well, I've got a over x here, just like the last one. And I've got plus b over x minus 1. Now, since I have a quadratic here, the top of this is going to be cx plus d over x squared plus 4. Okay, so we haven't run into this yet. Okay, so anytime I have a quadratic, I'm going to have something that looks like that, cx plus d there. Okay, so now, of course, I multiply everything here by x times x minus 1 times x squared plus 4. Okay, it cancels all this stuff out. Leaves me with 2x cubed minus 4x minus 8. The x cancels this x and leaves me with a times x minus 1 times x squared plus 4. The x minus 1 cancels that, leaves me with b times x squared plus 4. Okay, then the x squared plus 4 cancels that x squared plus 4 and leaves me with cx plus d. Notice I put that in parentheses, times x minus 1. Okay. Now, what can I cancel stuff out and make 0 with here? Well, I can let x equal 1. So we're going to let x equal 1. When x equals 1, this is 1 times 2 is 2, minus 4, which is negative 2, minus 8 is negative 10. So I get negative 10 equals, and over here, this all goes away. I get b times 1 times 5. Remember, I'm putting the 1 in for x. So 1, and this is 1 plus 4 is 5, plus cx plus d times 1 times 0, times 0. So that goes away. So I don't need this at all. Okay, so 5b equals negative 10, so b is negative 2. So we know what b is. So that worked out pretty good. Now, if I look here, I can make this go away if I plug in 0. That also makes this go away, so that's handy. So we're going to let x equals 0. Well, that makes this over here negative 8. Let's see, if I plug in 0, I get a times negative 1 times 4. And then again, all of this goes away because that's 0, blows up all this, that's 0, blows up all that. So negative 8 equals negative 4a, and so a ends up being 2. So now I know what a is. Okay. Now, I'm on this third one, I'm going to let a equal 2. I'm going to let b equal negative 2. And then I can pick anything that I want for x. Okay, I'm going to pick something easy, something simple. So I'm going to let x equal 2. Okay. So what does that do? If x is 2, then this is 8, 16 minus 8 minus 8. That's 0. So 0, that's a nice number, is going to equal 2, because a is 2. X is 2, so that's going to be 1. X is 2 here, so that's 4 plus 4 is 8. Okay. And then I get, let's see, b is negative 2, so this is minus 2 times x is 2 again. And then this is 4 plus 4 is 8 again. Okay, plus, all right, c times x is 2, so this is 2c plus d. X is 2, so this is times 2 times 1. Okay, so 0 equals 16 minus 32 plus, if I distribute that 2 times 1 is 2, I distribute that, I get 4c plus 2d. Okay, so this is going to be negative 16. If I add it over here, I'm going to get positive 16 equals 4c plus 2d. And you know what? I can actually divide that whole thing by 2 now that I think about it, and I'm going to get 8 is 2c plus d. Okay, now I've got to do this again. I've got to pick some other number for x because I have 2 variables in an equation, and the only way I can do that is if I have the only way I can solve that is if I have another equation. So this time I'm going to pick something simple again. I'm going to let a equal 2 because that's what it equals. B is of course negative 2, and this time I'm going to let x equal negative 1. Okay, if I do that, negative 1 cubed is negative 1 times 2, that's negative 2. Let's just write that down. Negative 1 times negative 4 is plus 4. Minus 8 equals. Okay, so a is 2. X is negative 1, so that's negative 2. That's 1 plus 4 is 5. Okay, so that's the first term. Then my b is negative 2, so minus 2 times x is negative 1 again. This is going to be 5. Okay, plus cx plus d. Cx plus d times x, which is negative 1, and then this would be negative 2. So negative 1 times, I'm run out of room over here, negative 1 times negative 2 is going to be positive 2. Okay, so let's see, this would be negative 6 equals negative 20. Those cancel. That's plus 10. Plus 2 times cx plus d. So this is negative 10. If I move it over here, that's going to be plus 10 to both sides. So that's going to be 4 equals 2 times cx plus d. And I divide by 2, and I get cx plus d is 2. Okay, I've discovered I made an error here. So I forgot that this x right here is also negative 1, which puts a negative 1 in here, which makes this negative c plus d. So I get this. Okay, now I have 2 equations and 2 unknowns. So I'm going to take this equation right here, I'm going to take this equation right here. 2c plus d equals 8, and negative c plus d is 2. I can multiply this bottom equation by -1, which basically changes that to positive and makes this negative, makes that negative. Combine these two equations, I get 3c is 6, and so c is 2. And once I know what c is, I can plug that in up here. Okay, and I get 4 plus d is 8, and so d is 4. So now I know what a, b, c, and d are. Okay, so I can go back into this equation, and I can write my new integral. My new integral is going to equal, okay, a over x. So a was 2, so I'm just going to put the 2 out here, 1 over x dx. Okay, b is -2, so I'm going to factor that out, times the integral of, where am I, 1 over x minus 1 dx. And then my next step is going to, let's see, this is going to be plus the integral of 2x plus 4 over x squared plus 4 dx. Okay. So I just got to integrate these separate pieces here. So this is going to be 2 natural log absolute value of x. This is going to be minus 2 natural log absolute value of x minus 1. Plus, now I can use u substitution. Can I use u substitution on this? No, actually what I'm going to do is I'm going to break this thing up into 2 separate equations. So this is going to be the integral of 2x over x squared plus 4 dx plus 4, the integral, okay, let's just put the 4 right there, x squared plus 4 dx right here. Running out of room. Okay, so I just broke this fraction in half here because I can use u substitution on this part. So this part right here is done. I don't really have to do much with this, except copy it down. 2 natural log absolute value of x minus 2 natural log absolute value of x minus 1. Okay, let's look at this part right here. So on that, I'm going to let u equal x squared plus 4. Then du is 2x dx. So this ends up being plus the integral of 1 over u du. Okay, which we know is the natural log of absolute value of u. And then I can go back in and substitute the x squared plus 4 into there later. Okay, this right here, this is an arctangent equation. So this ends up being plus 2 arctangent of x over 2. Okay, this is 2 squared over x squared plus 2 squared. So that's the formula for the arctangent. And then I'm going to go ahead and add c onto here. And so then I just need to put my x squared plus 4 back into this. 2 natural log absolute value of x minus 2 natural log absolute value of x minus 1 plus natural log of the absolute value of x squared plus 4. That's terrible 4. Plus 2 arctan x over 2 plus c. And we managed to cram that entire thing onto this little tiny dry erase board.